All right, hello everybody. It's been a while. Today is going to talk about lesson 9, which is efficiency and power. I'm going to go over what efficiency and power is, and it's going to be split into 2 videos, one about efficiency and one about power. So I'm going to go over the definitions and also like practice problems involving them because it involves some math. So what we're going to do today is we're going to be able to describe how much energy is totally converted to a desired type with using efficiency and to calculate the power of a system. So let's give the definition of efficiency. Efficiency is equal to the output work divided by the input work. So basically, whatever total energy we put into the system is in the denominator, and how much we get out is the numerator. So whatever we get out divided by whatever we get in. So let me go over the example and I'll show you the equation to get a better way to look at it. So a power plant produces 750 kilojoules of electrical energy after burning 1,000 kilojoules of natural gas. What is the efficiency of the power plant? So we have 1,000 kilojoules of natural gas. That's how much we have inside the system, and then 750 kilojoules of electrical energy. So if you remember about converting energy, we converted thermal to electrical. But let me go over this example. All right. So like I mentioned, efficiency, we either write the whole word. Oops. Or some people just do this symbol, which it's not an N, it's called something called mu. I'm just going to use that. This equals output work or output energy, output E, divided by input E. And we should do it in a percentage. So problem 1. Let's go back to that. It says, once it's loading, a power plant produces 750 kilojoules of electrical energy after burning 1,000 kilojoules of natural gas. So natural gas is what goes in the system and electrical energy what goes out. To give you a hint, you'll never get more out energy, so you'll never get more electrical energy than what you put in. So it'll either be the same or less. Actually, more often than not, it's less because there's nothing that's been 100% efficient. So let me write it down. So in was 1,000 kilojoules, and out was 750. So we're going to have efficiency equals 750 divided by 1,000. If you get that, you get 0.75. You just use a calculator, which is the same as 75%. So this tells us that this power plant is 75% efficient. 75% of the energy burned from fuel goes into electrical energy. The rest of it just goes into other heat energy that just escapes out of the power plant. Right? So let's do another example. Randy puts 7,500 joules of work into pushing a box up a ramp. Only 6,700 joules of energy actually go into moving the box. The rest of the work overcomes friction between the box and the ramp. What's the efficiency of the ramp? So this is like what I said last time. Even though Randy's pushing 7,500 joules of energy, some of that, the friction causes heat to remove some energy, so only 6,700 joules of energy is actually moving the box. Anyway, let's just do that example. So 2. We have in equals 7,500 and out equals 6,700. So what you're honestly going to notice is that efficiency is usually the small number, which is 6,700 divided by the big number. And when you calculate that, let me do that very quick. you'll get around 0.89, oops, which is just 89%. So in this example, the pushing the box was 89% efficient. The rest of the energy went out to be friction or heat energy. Another thing you can do, let's go back to number 1. All right, let's do this in another color pen. So let's say we had the efficiency 75% or 0.75, and we had how much energy we put in. So N equals 1,000 kilojoules. You can find out how much energy we actually get out by just using the efficiency and N. It's just basic algebra, so we don't know what out is. So we don't know that. Let's just say that's X. So if we use the efficiency equation, we know that this equals out divided by N. So that means 0.75 equals whatever X is divided by 1,000. So you can see we have the efficiency, we have the input energy, we just need to find the output energy. So this is solve for this. You just multiply 1,000 to both sides. So 1,000 times 700, 0.75, that's just 750 equals X. We can work backwards, basically. The last thing I want to go over is you can do multiple efficiencies. What I mean by that, let's see. Let's say the total N is, again, 1,000 kilojoules. And this time, let's say it goes to a boiler, which has an efficiency of 50%. Let's do B. And a turbine, that's just another machine. And that one has efficiency of 75%. Okay. In this case, we did last time 1,000 times, if we go back to the previous problem, 1,000 times 0.75 to get the answer. For this case, you're going to multiply to all of this. So to find that efficiency, you do 1,000 times 0.75 for one efficiency, and you multiply by the other efficiency, 0.50. Right? So if you have multiple efficiencies and just one input efficiency, you just multiply everything together, all the numbers. So 1,000 times 0.75 times 0.50 or 0.5, and you get the output energy as 375 kilojoules or out. That's how you do for efficiency.